we are writing R2 square as R square plus D square minus 2RD cos 180 minus theta. As per the cosine law, we have written this equation as we have already written in the case of R1 square. But here the theta is written as 180 minus theta, because if this is theta, if this angle is theta, this angle will be 180 minus theta. What is the value of cos 180 minus theta? We know that cos 180 minus theta equal to minus cos theta. So if we substitute 180 minus theta as minus cos theta, we will get the equation R2 square equal to R square plus D square minus 2RD into minus cos theta. If we multiply this minus sign and this minus sign, minus into minus, we will get plus sign. Thereby, the equation now becomes as R2 square equal to R square plus D square plus 2RD cos theta. Previously, the sign in this place is minus 2RD cos theta. Now we have got plus 2RD cos theta. Then if we divide and multiply all the terms of right side by R square, we will get R square into R square by R square plus D square by R square plus 2RD cos theta by R square. So if we simplify R square by R square, we will get 1 as in the previous case. If we simplify 2RD cos theta by R square, we will get 2D cos theta by R, because one R will be cancelled. Then we are writing the D square by R square term as it is. Then our next step is we are going to neglect the term D square by R square due to the reason that distance D is much less than R. So if we neglect the term D square by R square, we will get the equation R2 square equal to R square into 1 plus 2D cos theta by R. Now we have got the equation for R2 square, but we need the equation for 1 by R2. So from the equation of R2 square, we are going to find the R2 by square rooting both sides. If we find the square root both sides, we will get root of R2 square equal to R square into 1 plus 2D cos theta by R. If we square rooting R2 square, we will get R2, and if we square rooting R square, we will get R. We will get 1 plus 2D cos theta by R, the whole power 1 by 2. Now we have found the equation for R2, but we need 1 by R2. So now from this equation for R2, we are going to find the equation for 1 by R2. If we reciprocate all the terms placed in the left side as well as right side of the equation, we will get inverse of R2. that is 1 by R2 equal to 1 by R into 1 by 1 plus 2d cos theta by R the whole power 1 by 2. If we bring the factor placed in the denominator, that is 1 plus 2d cos theta by R the whole power 1 by 2, to the numerator the sign of the power will be changed, so that the equation obtained is 1 by R2 equal to 1 by R into 1 plus 2d cos theta by R the whole power minus 1 by 2. Then using the binomial theorem and neglecting the higher powers, the equation becomes as 1 by R2 equal to 1 by R into 1 minus d by R cos theta. The students can see my separate videos to understand the concepts of cosine law and binomial theorem in detail. Then we have already found 1 by R1 equal to 1 by R into 1 plus d by R cos theta. As per the superposition principle, the electric potential due to dipole is the sum of the potentials of the charges plus q and minus q. What is the formula for electric potential at a point due to an electric dipole? V equal to q by 4 pi epsilon naught 1 by R1 minus 1 by R2. Now we have found 1 by R1 and 1 by R2. So if we substitute 1 by R1 and 1 by R2 in the place of 1 by R1 minus 1 by R2, we will get electric potential V equal to q by 4 pi epsilon naught 1 by R into 1 plus d by R cos theta minus 1 minus d by R cos theta. If we remove the brackets, we will get 1 plus d by R cos theta minus into plus minus, therefore minus 1 minus into minus plus, so that plus d by R cos theta. On seeing this equation, we can cancel this plus 1 and the minus 1. Here there is 1 d by R cos theta. Here there is 1 d by R cos theta. If we add both these terms, we will get 2 d by R cos theta. Then we are going write the equation as V equal to 1 by 4 pi epsilon naught q into 2d cos theta by R into R, that is R square. Why we have to write the equation for electric potential in this format? Because we know that the formula for the dipole moment is q into 2d, so that we can substitute the dipole moment P in the place of q into 2d. For that purposes, we have written q into td nearby. Then we will get the electric potential V equal to 1 by 4 pi epsilon naught P cos theta by R square. Now we have derived the formula for electric potential at a point, that means at any point due to the dipole. Then we are going to see some special cases. What are that special cases? When the point P lies on the axial line of the dipole on the side of plus Q, the angle equal to, that is theta equal to 0 degree. We know that the value of cos 0 equal to 1. If we substitute 1 in the place of cos 0, we will get the electric potential equal to 1 by 4 pi epsilon naught P by R square. Then in the second case, when the point P lies on the axial line of the dipole on the side of minus Q, the angle will be 180 degree. We know that the value of cos 180 degree equal to minus 1. So if we substitute minus 1 in the place of cos theta, we will get electric potential equal to 1 by 4 pi epsilon naught P by R square into minus 1. If we bring the minus sign in the front, we will get the electric potential capital V equal to minus 1 by 4 pi epsilon naught P by R square. Now we have seen two cases. One is when the point P lies on the axial line of the dipole on the side of plus Q. The another is when the point P lies on the axial line of the dipole on the side of minus Q. Now we are going to see when the point P lies on the equatorial line, that is the perpendicular bisector of this dipole AB, what will be the electric potential. In this case, that is when the point P lies on the equatorial line of dipole, theta equal to 90 degree. We know that the value of cos 90 degree equal to 0. So if we substitute 0 in the place of cos theta, we will get V equal to 1 by 4 pi epsilon naught P into 0 by R square, so that we will get the electric potential as 0. These three are the special cases. In this place, I want to remember the formula for electric potential at a point due to the point charge. What formula we had derived for electric potential at a point due to a point charge? That is electric potential V equal to 1 by 4 pi epsilon naught Q by R. But in this case, that is electric potential at a point due to dipole, we have got the electric potential V as 1 by 4 pi epsilon naught P cos theta by R square. Note the difference between these two formulae. The students can see my separate video to know the all formulae relating electric field and electric potential due to the point charge and electric dipole. My dear students, if this video is really beneficial to you, you can share with your friends and classmates. You can also subscribe my channel.